transformations of the sine and the cosine graph. This is when the topic starts to get quite challenging. In terms of your exam questions, normally we're going to refer to the letter in front of the function as a, the letter inside the bracket as b, this letter as c, and this letter as d. So what I've gone on is Desmos, and I've changed these letters to match with this. And we're going to talk about exactly how this changes the graph. So the first thing we're going to focus on is the amplitude. The amplitude easily, or quite rightfully, is represented by A. Let's look at Desmos. From what we've learned previously, we know that A is the distance from the midpoint of the graph to the maximum or the minimum. So in typical sine and cosine graphs, where it's just A is sine of x, so we substitute A for 1, B for 1, etc. We are going to get the following, an amplitude of 1. Now, if we change the amplitude, what are you seeing that's happening? Excellent. Hopefully you've realised if we increase the amplitude, the graph becomes steeper. And if we decrease it, so we decrease it to say 0.5, it becomes flatter. This is called the amplitude. Now, if we wanted to work out the amplitude of any graph, what you'd have to do is look at the A, or look at the number in front of the sine or the cosine. We're going to just focus on sine for now. You'd look at the number in front of the sine, and the number is going to be 0.5. Therefore, the amplitude of this particular function, where A is 0.5, is going to be 0.5. That's nice and easy. The period is a little bit more difficult. Now, typically, we have B is equal to 1. So if this is equal to 1, this means it takes 360 degrees for a whole cycle to occur, a whole period to occur. So we're going to focus on periods rather than amplitudes. Now, if I move this to 2, what do you notice has happened? Excellent. So the bigger this value comes, the more squashed the graph becomes horizontally. This is really interesting. If it's something within the bracket, so if the B or the C changes, it's the opposite of what you think. If the B changes and gets bigger and bigger and bigger, the more squashed the graph becomes. If we change the B back to normal, B back to 1, there we go. Whereas if we change the A, rather than the graph becoming more squashed, when we increase the A, it becomes more stretched. So I call this intuitive. When the A becomes bigger, it intuitively becomes more stretched and the values on the y-axis become bigger. So it's intuitive. Whereas things inside the brackets are counterintuitive. They're the opposite of what you think. So because the B affects the x-axis rather than the y-axis, because it's counterintuitive, rather than it becoming bigger for a period to occur, the cycle's becoming smaller. The cycle's occurring in a third of the time. It's useful to get the general gist of what I'm saying. Don't worry if you don't understand completely. Now, the next thing we're going to have a look at is the C. Now, if we have a look at C, this involves how much we're shifting the graph, left and right. Again, this is counterintuitive. So if I put plus 100, what direction would you expect the graph to shift. As you can see there, it shifted to the left. Let's go back. So if it was 0, and then if it goes 50, and then if it goes 100, the graph is actually shifting to the left. But you'd think because we're adding, it shifts to the right, but it's counterintuitive. So this is why we often put minus c, because if the graph has minus c and then we substitute c for 2, this means it moves to the right twice, because it's actually minus 2. It does the opposite of what you think. If it's minus 2, it moves to the right twice. If it's positive 2, it moves to the left twice. Let's show you exactly what I mean. So let's go back to 0. It's here. If we minus 2, it's going to move to the right. Starts at 2. And then if we plus 2, it's going to move to the left. Last but not least, we're going to talk about things outside of the bracket. So we're going to focus on D. D this time is going to be intuitive. It's outside the brackets. It's what we expect to happen. D is a vertical shift, a shift up and down the graph. So a key summary is that A and D will affect the graph vertically and along the y-axis, and then the B and the C affect the graph, the x-axis of the graph. So let's say we're going to change the D. Let's change D to 5. Now what you can see here is it's shifted up 5, whereas if we change it to minus 10, it just shifts down minus 10. Let's think of a bit of a summary. This is a great summary for you to have a look at. I'd pause the video and write about this now. And I might just summarise some of the things I've just talked about, because some of you might find this topic very difficult. If you did extended maths in M5, you would have already covered this topic. So the first point I'd like to make is that the A and the D affect the y-axis, and we would like to say that they affect the y-axis intuitively. It's what you'd expect to happen. So what I mean by that is if A gets bigger, the amplitude gets bigger. Similarly, we said about D. D is to do with the shift, the vertical shift. If D gets bigger, the graph is shifted in a positive direction in the y-axis. Now let's talk about the B and the C. Remember, they can change these letters around, but for your course they probably won't. So we're going to say that the B and the C affect the x-axis, but this time we're going to say they affect the x-axis counterintuitively. It's the opposite of what you would expect. So if we are going to change the B, we said the B is to do with the period. So if B gets bigger, then the period gets smaller. So if we change B from 1 to 2, changing B from 1 to 2, you're going to make the period smaller by 1/2. The reason why that is because you take the 2 and you do 1 divided by 2. Now similarly with the C, if we change the C, if we increase the C, then the graph will be shifted to the left. Whereas if we make the C, decrease the C and make it smaller than 0, then it's going to be shifted to the right. What I would recommend you doing is playing around on Desmos if you don't understand this. But we are going to do some questions now. And you don't need to understand all these parts if you're happy not getting a 7. This is more for people who really would like to get a 7. So, these are a couple of questions. We've talked about sine and cos. What we now need to talk about is this function. So we have changed the a to a 3. This means the amplitude is 3. We have changed the b to a 2. This affects the period, not the amplitude. The period, rather than being 360, is going to be half, because this is a 2. If this was a 3, it would be 1/3. So it's half of 360, which is 180. The -2 represents the vertical shift, which means the whole graph becomes or starts at -2. We call this principal axis because the amplitude is 3. It will start at -2. It will get 3 bigger than this for its maximum, reaching a 1 for the y-axis. It will return back to -2, and then it will get 3 smaller, landing on -5. So if you wanted to write the range is between -5 and 1, just explained. X can be any value, so you can say X is in R, the period as discussed, the principal axes. Now you can do this using the equation. Effectively what they've done is they've added the smallest, the largest range numbers divided by 2, or you can just use your head. This number's -2. If D is -2, the principal axes, or where the graph starts, or where we have this axis of symmetry, is going to be simply -2. Now let's get on to a question finally. The graph of a function of the form is shown on her GDC. Write down the amplitude. Now we can look at the amplitude using the picture. The amplitude is the distance from the x, or the principal axes, to the maximum and the minimum. So, you might not be able to realise this, but this is jumping up in tens, 10, 20, 30. Because this is the principal axis, our amplitude is going to be counted from the x-axis. Therefore, the amplitude is 20. So our answer is going to be 20. This is their description. Any description which is similar to what I've just said or similar to this would get you the answer. Now, here it's got the mod sign. A mod sign just means you take whatever value is in front of the sign, you change it to positive. This is why we take the -20, we change it to +20. Now, the next question is asking us about the period. The period is always affected by the number in front of here. This is going to be 3. So what we do is we're going to say that the graph is going to be squashed. So it's going to be 1/3 smaller than normal. Normally it would be 360, so 1/3 smaller would be 360 divided by 3, which is 120. If you wanted to use the picture of the graph, you could see when one full cycle completes, it's going from the minimum to the maximum, back to the minimum again. So a cycle is completed after 60, 120. Now this question is a lot more challenging. It wants you to calculate the A, the B and the D just using 2 coordinates. How difficult is this? But we can do it, I promise you. The first thing I would do is draw a sketch. Now I'm going to think about what information is easy to calculate. The first thing I would add to this sketch is my principal axes. Now my principal axes is going to be halfway between the minimum and maximum. So it's going to be around about here. The next thing you would do is you'd work out what is this principal axis. Well, the principal axis is to do with the y value, so it's going to be halfway between the max y value and the min y value. So to find out halfway between, you would add them together divided by 2. It's like finding the mean of the two values. You should know this skill. This is going to be 16.2 divided by 2. The y value for this is going to be 8.1. This is really useful. Working out this value will tell you what D is, because 8.1 gives you where it crosses the y-axis. You can see this because the midpoint of the graph starts at the y-axis, and the reason why we have this is because we've got no C. If we've got no C, it will start here. Therefore, our principal will be the y-intercept. Our y-intercept, therefore, is 8.1, so this is going to be D. The next thing you need to calculate is the A. So the D and the A are easy to do. All you need to do is you need to work out the distance from the principal to the max or the min. So the distance from 8.1 to 11.2 is just going to be 3.1. So our A is going to be 3.1. Look, we've already calculated the A and the D. And if you're not sure about calculating the B, that's absolutely fine, because you would have got most of the marks by now. You might want to give up at this point. Last but not least is the B. So you've got to see what is the period of this. Now, the distance from a min to a max, or from a max to a min, will give you half of a period. 3 to 9 is half of a period. Our full period is going to be 12, because 3 to 9 is 6. Double of 6 is 12, so we know the period is 12. But that, unfortunately, doesn't give us B. We know that the period is given by 360 divided by B. Now we know that the period, we know the answer, but we don't know the equation. We know the period is 12. So all you need to do is solve this algebraic equation. To solve a simple fractional algebraic equation, the B is going to move up to the top, and the 12 is going to move down to the bottom. Simple as that. Then we're going to have B is equal to 360 divided by 12, which is going to be 30. So we've got A is 3.1, D is 8.1, and the period is going to be 30. Let's just double check our answers with this. 30, 8.1, and we had another thing, 3.1. I believe these are the answers that we managed to glean, which is fantastic. Now, what I'd like you to have a go at is these challenging questions. I'm going to zoom in. I'd like you to take a screenshot of this. And now I'm going to scroll to the bottom, and you're, last but not least, going to take a screenshot of this. Good luck.